All right, so here's where I left off, and we're ready to go into our final session. And we probably won't go all the way to the scheduled time. It depends on how this is going to be a hands-on interactive session. So if everyone's engaged and we're really having fun with this, we could stretch it longer, depending on all of that, or it could end up being a little shorter too. So it's I know exactly how it plays out in an in-person setting. In a Zoom setting, it's a little different. So we're going to see how that goes. The session 3 is again hands-on drainage water management design. We're going to have some fun with this and hopefully learn some more too. And as with the other sessions, we'll start with a poll question. So do you want to launch that, Keegan? How important is elevation when zoning a DWM system? That's great. Yeah, probably that first answer is perhaps the best answer, but I can't say number 3 is wrong either. Elevation, elevation, elevation. It's crucial. Topography. So hopefully you have your contour maps at the ready. We're not going to look at all of these, but we'll look at as many as we're comfortable doing. And again, we'll start with a handful of pretest questions. So Keegan will be sharing, or has already shared the link, in the chat. So go ahead and take a couple of minutes and look at those, please. Thank you. We'll give you a couple of extra minutes on this one because might take a little bit more thought, especially on that last question. Give us a thumbs up in the chat as you're completing that. I don't want to rush. Don't want to rush you. All right, seeing a lot of thumbs up now, so we'll move ahead. Hope you got them all right, but if you didn't, hopefully by the end of the day, we'll be set on everything. So this is going to be fun. We're going to look through your topos that Keegan shared with you earlier, and pull this one out, if you would please. So this is our retrofit design. A is what I'm calling it. I'll give you a second to find this drawing. Okay, hopefully you've located that. So you are now the planner, designer. And here's the scenario. Here's a field. It's got an existing tile system on it, as you can see. There's a single outlet location. And I'd like you to plan for, the client would like to have a 2-foot water management zone, or would like to use 2 feet for the water management zones. And I'd like you to place one structure on the system and sketch out a 2-foot water management zone above that structure or upstream from that structure, or the water management zone that structure would serve. And so take out your highlighters, your pens, whatever, your touch screen, and put a mark on here for where you're going to put the structure, and then decide where your 2-foot water management zone will start and stop, and shade that in. And I'm going to give you a few minutes to think about that and do it. This is in person. This is typically the time when we're walking around the room and talking with you as you work on this. But take a few minutes and sketch something out. We're not adding any more tile to the system. We're not putting in a new main or anything. It's just use the existing tile system and place one structure and sketch out the water management zone. Okay, hopefully that was enough time to really think about that a bit. And so let's think about a couple of possibilities here. I'm going to turn on my coloring book. And so our main goes along the bottom of the field here. And our structure has got to be somewhere on this main. We've seen before that we don't gain much advantage by putting a structure on a lateral somewhere. So our structure is going to be somewhere on the main. And then we're going to look up above that elevation to try to get our 2-foot water management zone. So you could look at this and say, the 5.5-foot contour, which is down here in the corner, is just a little corner of the field. I'd rather be on the 6-foot elevation so I could extend my zone up to 8 feet, perhaps. And if you were thinking that, okay, I need to find where the 6-foot contour line crosses that main, sort of if you're thinking along those lines, then you might have been tempted to put the structure somewhere down here. And if you did that, and then thought about a water management zone going from 6 to 8 feet, what would that then look like for a structure located right here? Well, we know we go from 6 feet up to 8 feet. So here's the 8-foot line here. And where do we stop with that 8-foot line? Can we just keep marching across the page? We cannot, because we have to stop at the last lateral that feeds the structure that we place there. So all the laterals in our zone have to flow into this structure. So that means we need to stop somewhere like right here. And that's what a zone would look like if you took that approach. Not wrong, no rights and wrongs here. It's all subject to interpretation, compromise, and so forth. Did anybody do something like this, similar to this, with a structure in a location close to this? Like any thumbs up or anything like that? I can't see, unless it's in the chat, I can't see it. Well, this would work. And of course, you see we're kind of limited in terms of area and the size of our zone. And we don't have a realistic location to put a structure at 8 feet to go up to 10 feet, not without doing something else. So let's take another crack at this, and let's go more toward the outlet here and do a couple of different things. Let's go for a literal approach and say, if we place an outlet right here, that outlet is at 5.5 feet. And by the book, that means our zone would go from 5.5 feet to 7.5 feet. So then we look for the 7.5-foot contour, which is right here. And depending on if we caught that last lateral or not, we'd have an area that looks like that. Did I do that right? 5.5 feet to 7.5 feet. Not too bad. That's maybe, I don't know, 40% of the field or whatever. Anybody do something like that? This is where Zoom is really hard. And if you did something like this and then thought, well, if I were going to put a second structure there, is there a possibility in there? I don't really see one. Again, because our tile is kind of running up and down the hillside. But I wonder if anybody thought about, placing the structure at where we have it here. And the 5.5 foot contour line really just kind of crosses over the corner of the field. What if we were to, let me clear my screen here. What if we were to place the structure as we did before, because it has to be on the main, and manage it for the 6 to 8 foot elevation difference. So manage it as if the start of our zone is at 6 feet, even though the structure itself is at 5.5 feet. Manage it for 6 feet to 8 feet. If we did that, then that would take us up to the 8 foot line here. And kind of would get this. Well, that looks even better than the previous scenario. I remember though that this is a 2 foot zone, so we're going to be 2 feet off the target depth on the high end of the zone. However, since it's a retrofit, we can't do anything about the placement of the tile. So perhaps better to get some control, even though it would be diminished with a large elevation change. But what I want to ask you about is what happens if we did it like I just pictured it here? What happens down here between the 5.5 and 6 foot contour lines? What's going to happen there if we're managing in our structure for the 6 foot contour?
Yeah, and Gary, I'm not sure if you can see the chat or not with your annotation on. We do have.
I can't, but tell me what you're seeing.
We've got some good discussion in a little bit, and
good.
The answer to that is saturating the soils, getting wet down there.
Exactly. Getting wet down there. So let me turn off my annotation, and if I go to the next slide and play that scenario out. So here's our structure at 5.5 feet. We want to manage around from between 6 and, well, I went to just pretend this is 8 feet here. That's what we'd like to do. And so of course we're going to, for a 1.5 foot zone, I had just used 2, but if it's 1.5, we're going to be anyway, we're going to be that much off on our high end. We know that. We're going to be at our target depth at the 6 feet if we're managing for that. But then back behind there, we're going to be deeper. The water table will be shallower than our target depth. So again, our target depth was 2.5. That puts us at 2 feet back here. And so that's something we have to ponder if we're going to take that approach. And maybe that's fine in this field, on this edge, depending on what's going on. Maybe it's not fine. I don't know how much total area that is, but whatever that ends up being for the field that you're working on, you'd have to consider that that area might get a little bit wetter than you want. And of course, remember what happens up above our water table depth. Remember, it's not field capacity all the way to the surface there. We only get to that as we get farther away from the water table. So keep that in mind. Again, something else we can compromise on as we look at these systems. This was just an an example of, again, looking at a retrofit on this for this particular field. Again, you'd have to cut in these submains here and establish all these new connections, and it would be very messy and probably not cost effective, I'm sure. So second scenario.
Hey, Gary,
Yeah.
This is Laura Christensen. I have
Hey, Laura. Yeah,
if it's okay, before you go on.
absolutely.
Some of the responses in the chat were that they had put the outlet 4 tiles or 4 laterals over on that last example, and you left the outlet, you left the control structure at the outlet. And so I'm just curious, your thoughts on that.
Thanks for pointing that out. And yeah, when I'm in this annotation mode, I can't get at the chat. So it sounds like you're saying that, let's see, 4 laterals over where the 6-foot line comes closer to the main there.
Yeah.
1, 2, 3, 4, maybe in here, something like that.
Yeah, I thought that was a really good idea.
Yeah, I think that's a great idea. That's a great idea. And I would say that we still don't get around the fact that, again, this whole area down here, oops, I'm drawing rectangles here that I don't want. I want to just scribble. This whole area down here is we still run the risk of that saturating that area. Because even though we're closer to the 6-foot line at our structure, the field dips down below that. So we still have that saturation issue on the edge of the field.
Do you see a benefit of putting it over? I guess I'm curious why the people who put it over 4 laterals, why they did that. What's the benefit of scooting it over? Because
I think it makes sense to, it certainly makes sense as you look at it, saying, oh, I want to give up the 5.5. I want to go for 6 to 8. And that's 6 comes awful close to the main there. So I understand, why you would do that. But then if you just think about the plumbing there, you're still managing for 6 feet when some of the tile in your zone is, goes through an area that it's lower than that. And so I don't know if anyone has got something they'd like to share about that.
Gary, this is Vinayak.
Yeah.
Just thinking out loud here, shouldn't the discussion in this case be more about where you want to set those boards up, the management of the structure itself, rather than trying to figure out the zone? Of course, we want to maximize the zone. That's the idea. But then it also comes to the discussion of how you manage these structures and when. If you're running the risk of having high saturation, maybe you just want to lower the boards a little bit during that time, but then during non-growing season, you can still set the boards up high enough that you can maximize the zone of influence for the water quality benefits. If that makes sense, I think it kind of depends on the objective here. Are we trying to reduce the water and nitrate, or are we trying to maximize the benefit to the crop yield?
Yeah, I think that great points, Vinay. And of course, we're trying to do is the best we can do on both of those things. And yeah, the management is key, and it's going to look different different times of the year. Where is this field? Is it east, higher rainfall? Is it west, lower rainfall? All of those things are going to come into this. What are these soils? Are they more prone to ponding than not? So all of that that is going to factor in. So right now we're trying to get our heads around the sort of the structure of a system that's going to allow us to manage, and what that's going to give us, what possibilities that's going to give us in terms of water table management. And so, yeah, the ensuing management will be key, but then also, I just want to make sure that folks acknowledge the physics of the system, depending on, again, how we place our structure and what we're attempting to do, how the system is going to work from a physical standpoint.
One more point I was going to make was, just because the surface profile drops by 1/2 foot in those 4 laterals doesn't mean that the main drops by that much. It's running at a certain grade, so you got to think about if it's 200 feet or whatever between those laterals, then at a 0.1% grade, it's only 2 inches of drop, not 1/2 foot of drop on the main itself. I don't know if I'm making any sense.
Yeah. Oh no.
That
There's a question here. Could the zone go to 3 feet? It could. And if this were a field where you were really trying to do something here, and you knew you were only going to be able to put one structure out there and do the best you could with it, in a sense, you are gaining some water table management at the high end of the zone, up until the point where your laterals are really higher elevation than your desired water table. If you think about wherever you put the water table setting in the structure, your zone is actually going to be as big as, it might even be bigger than 2 feet. But where you have where you have laterals that are actually higher in elevation, obviously you're not going to be controlling anymore there. So it's kind of a different situation where you don't get to sort of plan out the zones from the get-go. Where if we were doing that, then we would be planning our second zone starting at that 2 foot mark. Good discussion, really good discussion. Let me throw another scenario at you here. We talked about that retrofit. Now we drop into the same field, rewind, but lo and behold, it's a different drainage system on this field. It was put in now with a little bit more on the contour here. Same outlet location, although there doesn't really show there to be an outlet pipe, but just assume one is there. And what I'd like you to do now is do the same thing. Let's assume we have a 2 foot water management zone, and you have 2 structures to work with. So let's do the same thing. Place your structure where you think it's appropriate and sketch out both of your 2 foot water management zones. And I'll give you a few minutes to think about that and to do that. And then I might try to see if Keegan can put us in a speaker mode and get a couple of you to hold up your sketches so we can see them. Okay, let's see if we can find a couple of brave souls who want to share their work. See if that even works. Can you put us in speaker mode, or is that an individual thing that we all have to do on our end, Keegan?
So now I have it in speaker.
Okay, so it doesn't. Yeah, I don't see it that way, and I'm guessing others don't either.
Be my guess.
So if you look up in, if you all look up in the upper, hopefully it's the same place for everybody, the upper right-hand corner of your Zoom screen, you can change the view there from gallery to speaker. And then if someone wants to share their drawing by holding it up, they could unmute themselves and maybe have to make a little noise so that we see their screen. Let's see, speaker mode put you, when I do that, Keegan,
Mm-hmm.
I see your box takes up the screen because it shows you as speaking. You got for some reason.
What
Yeah, I don't
happened?
know.
What happened?
Now we see Laura. It's popped up on mine as large. It's not a competition, right?
It is for us.
It is. That's what I mean.
How do
That's
these
what I
come for
mean.
you?
Can you see okay?
Yeah, I can see those.
Okay,
Maybe
we'll
back up just a teeny bit. Yeah. Okay. So good. So you've got yours. Well, you just tell us what you did.
I did one right at the bottom of right near the outlet at about 5.5, and then that controlled the area up to about 7.5. And then I did my second control structure right there. So I'm missing a small triangle of the field in the middle, and then also at the top.
That's really good. So tell me, Laura, how come you weren't able to, when you said you're missing that triangle there, why weren't you able to shade that in as belonging to zone 1 or zone 2? Or is that why doesn't that belong to zone 2?
Well, I cut off zone 1 along the 7.5 line, and then I cut the bottom of zone 2 along the lateral, which was the bottom lateral where the structure was located.
Right. So those laterals that are in that triangle there, they feed that first structure. They don't feed the second structure, so they can't be considered.
Right.
You know that. I'm just
Right.
pointing that out for others. They can't be considered to be in zone 2 because those laterals aren't part of that. They aren't in that zone.
Yeah.
Plumbing wise, what you got, Reed?
Yeah.
Well, I did something similar, but I don't know if you can see that there. I put,
Oh yeah.
since we grabbed such a big chunk of the field, you know, about half or so with having that control structure at 6 feet, I decided to go from 6 foot up to 8 foot, follow that contour line around. But that did leave me a little bit shallow or a little bit light on that top zone where, again, since that lateral is controlling it, but that's the southern border or the bottom border. So that second structure then is only really going to grab these first at the top 1, 2, 3, 4, 5 laterals across, except for that tiny little triangle there right at the 10-foot contour line.
Right.
So dropping that off, and then still a similar gap that Laura showed right here that isn't being controlled at all.
Right. Very good. Thank you, guys.
It was hard,
It was what?
harder than I thought.
Would someone else like to show what they came up with? Now, in my Zoom here, since I put it in speaker mode, I was able to see that large when Laura and Reed were speaking there. So the rest of you can do that too, I think, if you put yourselves in speaker mode. So would anyone else like to share? So Vinay said, just double click on the video of whoever's doing the design. That's good. You'd think I'd know how to use Zoom after 2 years.
Vinayak always has the best Zoom tips I've come to find.
Ah, I see. Well, we're really fortunate to have him here. So
Yeah,
if
I
I
did a
double,
similar design to Laura,
okay,
I guess. And so did,
same as Reed, same as Laura. Anybody have something sort of remarkably different from that?
I guess
Okay,
I'm gonna acknowledge a mistake I made just so that
good.
learn from the mistakes. When I drew the zone of influence for my structure close to the outlet, I didn't think about, I just kept following the contour line. So my zone of influence went into the zone, the second zone, upland, thinking that it will control that. So I'm still thinking about whether or not it will. Any thoughts on that? I can do a screen share if it helps.
Yeah, go ahead and do a screen share if you'd like, if you can.
Talking about this red line right here.
Yep.
So if you're controlling this structure and this structure at the same time.
Yeah. So I think, when I sketch these out on my own, I would just kind of circle that area and say, okay, we have kind of a little bit of a crossover here.
Mhm.
This is, yeah, we're not trying to land somebody on the moon here. So I don't think it matters too much what's happening right there, control wise. But otherwise, you've got essentially the same thing that Laura did here.
Yeah.
And that's good. So while you have that up there, you want to leave it
Sorry.
up?
Yeah.
So I want to make sure everybody's clear on why the laterals that are on the right side of this zone 1 are left out, don't belong in either zone. And I want to make sure people understand that, because it's common to, I've seen many people when they would sketch out zone 2, and they would just include that area as belonging to zone 2 because it falls within the 7.5 to 9.5 foot contour. But I just want to make sure people understand that the laterals in there, they don't flow into the second structure. Exactly. They don't flow into the second structure at all. They're plumbed into the first structure. So you can't control what's going on in those laterals with your second structure. And that's why you have to leave it out. When you're doing these plans for the NRCS or whatever, they'll flag that. You can't include that as an impacted area. Now, that said, those laterals are, the endpoints of the laterals that are in the red zone in zone 1 there. There's got to be some measure of control there, even though they fall outside of the 2 foot zone that you're designating for this system. You're going to have some. There's going to be some. It's not going to be zero effect out there as well. It's just in a formal way, we don't count those as part of the impacted acres. So Taylor asked, would you start your second control structure up higher just to avoid that overlap? Personally, I wouldn't worry about the overlap, but you could do that. You certainly could do that if you wanted it to look cleaner. Start that second structure up 1 lateral higher, something like that. But I don't know what the NRCS would say when it comes to counting acres here, and whether or not that would be double counting or not. It seems a bit nitpicky, but you certainly could do that, Taylor. And John asked, what if you place the main southwest and northeast with laterals flowing in like a herringbone design? I'd say, let's just wait for that. Right now, we're working with an existing tile system and we're trying to get the best out of it. So while Vinay's got his drawing up here, I just want to make the point that both design retrofit B and retrofit A, the one that we just did previously, they both had existing tile in them. But look at how much more of the field we're able to control with scenario B compared to scenario A. And it all comes down to the orientation of the tile. Even though it's not perfectly aligned with the contour, and it did leave a gap over there in the yellow area, just because the tile is much more aligned with the contour, we come out far ahead of where we were in scenario A. So even though, you know, this might not have been designed with drainage water management in mind, if they were doing a good job and kind of staying more on the contour than opposed to the contour, it set itself up much better for drainage water management, even though it was still a retrofit. And even though there's still some areas that kind of fall outside our control. Any comments, questions, thoughts on this before we go to a third scenario, which you're really going to enjoy?
I have one question. This is Ben.
Hey, Ben.
And I don't know if anybody on the group, you know, feel free to speak to this, but like in the yellow triangle, so if we imagine upstream of it, the blue area being a controlled area, could we expect, and if so, how much might we expect there to be any type of lateral flow downslope into that yellow area? And so, you know, Gary, I think when you were saying, well, that yellow area probably has some level of control, we were talking about the east-west, what I'll call east-west laterals within the red zone, right? Extending, extending upslope. But I would also expect there to be some kind of lateral, kind of upslope from the north, I'll call north, lateral flow downslope into that yellow area as well. Is that
Yeah, I agree.
true or realistic?
I agree. I think so. You know, to what degree, I don't know, but some,
Right.
sure. Yep. It's probably not zero.
Yeah.
It's probably not zero. And, you know, kind of related to that question, those of you thinking about, you know, we've talked about this practice and reducing drainage outflow, and of course, nitrates and other things that are in the drainage water. Those of you who work with, you know, in the area of hydrology and have to look at water balances and so forth are probably thinking, okay, so we reduce the drainage outflow, but we still have a mass balance of water to deal with. So where's the water going? If we reduce drainage outflow with these systems, where then will that water go that's not leaving through the outlet? Any thoughts there?
Deep seepage or lateral seepage?
And evapotranspiration.
That's got to be
Yeah.
one place. That's got to be the second place, right? Where else could it go? Is there any other place it could go? Deep seepage or lateral seepage? Seep laterally away from the field, seep vertically below the field, or evapotranspiration. Again, with a wetter, in general, on average, with a wetter soil profile, as long as we have a healthy crop, again, it's not too wet, we could expect an increase in evapotranspiration. The models suggest this. So that would be the second place that this water could go. Any other thoughts on that one? Okay, great. So if you don't mind, Vinay, I'll go to the next scenario, the third scenario. And you probably knew this was coming, and this might satisfy John with his last question. There's no tile in this field now. And so you get to plan this thing from the start. So it's really game on now. You can use as many structures as you want. You can put the tile wherever you want. And so I'd like you to take a few minutes and think about your tile layout and your zones and kind of sketch out how you might approach this. Again, with a water management zone of 1.5 feet or smaller. You can put the tile anywhere you want. Sketch in a couple of laterals. Don't draw anything to scale. You don't have to pull your ruler out, but if you want to, that's fine. But I'm not looking for a really polished drawing, but see if you can delineate your zones now and figure out where you'd place structures and where you would put the tile mains and laterals, excuse me, to make it happen. So go ahead and take a few minutes. I'll give you a few extra minutes on this one because you've got more to think about. And Keegan, what did you say the prize is for the person that can get 100% of the area of this field? I'm just kidding.
They get a guest host the next virtual training.
So see what you can do with this, and I'm sure we'll have a wider range of examples when you're done. Let me also add that we're still limited to one outlet. Okay, so whatever you do, you've got to get all your water to that one location. Do we need more time? Okay, I'm wondering if we can get any takers for sharing their work. It's a friendly crowd now, so you don't have to be scared.
I can share.
Is that you, Ben?
Yes.
Great.
Oh, my blurry screen may
Yeah, there you go. Okay, back up a little bit. There you go.
okay. So I started out at the 5.5, went up to 7. That's my first zone.
Mhm.
Then 7 to 8.5, and then brought a submain across, and so 8.5 to 10. And so I missed the very top of the hill up here in the corner. But the 3 structures based off the 1.5 foot.
That's excellent.
Zone 3.
And I hope everybody can see, I can see it pretty clearly here, that you see how he sketched in enough laterals so you can see that, you've got to do some more creative things with the laterals. We're not going to be able to just go straight all the way across the field from left to right and pick up the whole area. And so his zone 2 there, where he teed off of that one lateral to go down southeast and pick up the other part of that zone. That was the part that we missed in the last scenario, because of the tile orientation. But now we can pick that up and make that part of zone 2. And of course, he had to do something similar up there in zone 3 to get to that whole zone. That's great. Any other thoughts, Ben, or any comments by others, either in the chat or verbally, if you want to share?
I wish every field was this flat.
Yeah. That's the challenge is with this, is looking for those opportunities. Are there areas within the field that that offer themselves up and are large enough to make it worthwhile? If not, some organized approach to the whole field. I'm wondering, John asked before about going up through the middle of the field. Did you or did someone take that approach, and would you like to share?
I did. I don't know if you can see it. I'll try to make it somewhat visible. So this was kind of the opposite method of his, is going up through that center of the field and then kind of doing like a herringbone off of both sides. You have to run 1 or 2 submains along like the 8, 7.5 or 8 profile, but that gives you less connections and smaller laterals in most of the field, and you can kind of cut it down to longer lines. But then you cover from pretty much 9.5 all the way down to 5.5, and you lose a little bit up in the top corner, but it's not too bad. I don't know if that would be a better way, but something like that.
That's great. That's great.
Does that mean you would be putting a water gate in the middle of the, like an inline structure instead of a, so? 'Cause you have in the middle of
You
the-
could, otherwise, I know we talked about those two structures of the floats and maybe placing two of those along that sub main running up through instead of the water gate in the field itself. Because then that'll give you two 1 foot control structures in there and then one larger structure on the bottom. Maybe that would work, but not entirely sure. I guess it's up to the farmer if they want the control gate in the middle or not. It's a fair point.
Yeah. I mean, like the example that I had up earlier, our cooperator, we had structures all the way up through the middle of that field, and it was fine because of the equipment and the tillage that he was running. It wasn't a problem. So that's great. So did you have two structures there?
Yeah, two control structures, one at like the 5 3/4 mark and then one at the 7 3/4 mark. So that covered pretty much everything from 9 3/4 down. And you would just have to have the main on the bottom of the field a little higher.
Great. Thanks for sharing that.
This is Ann Baldwin from NRCS. I'll share mine.
Great. Hi, Ann.
Because it's a combination of everything you've seen so far. So
Yeah.
I started with the structure at the lower end. And then so that was for 1.5 feet. And then I put in 3 water gates for the 8, 9, and 10. 5.5 to 7. Yeah. So for 8, 9, 7, 8, 9.
Ah.
Sorry. Gotcha.
So the water gates at 1 foot intervals.
Yeah.
Excellent.
And just managing at the bottom. And but
That's
with
great.
the the line up through the field and the herringbone pattern.
Mhm.
So.
That's great. Thank you for sharing that. Do we have any contractors in the group here today? I'm just wondering how some of these approaches strikes their sensibilities in terms of installation, geometry, and so forth.
Yeah. Sorry, I didn't mean to take the time away from contractors. I just had a question on that, the design that Anne showed. How many inline structures can you put on one single control box before having to add another control box is a question. I thought it was only 2.
No, you can do more, but I don't know if there's a limit. Keegan or Mark or anyone else, have you had any discussions or heard anything from AgriDrain on any limitation? It's my understanding that there was no limitation.
Okay.
Yeah, I guess I'm not sure on that.
Yeah, I can speak to a little bit of that. This is Ben. So in a lot of our ESE designs, we'll go up to 3 inline structures on a submain above a regular water above ground water control structure. Once you start putting more on that, you can get a little bit of head loss as you put more in series, and so they become less and less effective as you stack, more and more on a single line. So we usually keep it to 3 or less.
Oh, that's great. That's great information, Ben. Thanks. A great question too, Vini. So I think in Ann's design, did you have 3, I think, in there?
Yes.
So you were spot on.
Got lucky.
It was great. It looked awesome.
Did anyone place control structures around the east side of the field? Certainly would have been one way to do that. Other than that, would anyone else like to share their design?
Gary, this is Reed. I had a quick question about the you obviously wanting to manage everything at a uniformly across the field, but would there be any issues mixing zones from 1 foot to 1.5 foot? Like if you're able to manage 2 zones at 1 foot and another zone at 1.5 foot, would that be a problem?
Well, that's an interesting premise. Like we were talking about in that previous example, it'd be reasonable to expect some lateral seepage from zones that are managed. Or no, wait, you're not talking about managing the water table at different elevations. You're talking about just changing the elevation drop within the zone, right?
That's correct, yeah.
Yeah. I see no reason why it has to be, for instance, Anne's design there, where she had a manual structure at the outlet and had a wider zone, and then had to go to 1 foot zones up above there. Just off the top of my head, I can't think of a reason why it would necessarily matter.
I guess it's gonna happen regardless. If you put something in, you're either gonna manage it at the top end or not, depending on water conditions, I suppose. Thanks.
Someone needs a project where they can develop a game to design these things with all the prices put in there and see if we can do it for a certain expense.
Like
Sounds
a
like a job for Laura.
sim DWM.
Yeah. Maybe it's out there.
Build your DWM city. So you did great with that. I want to acknowledge that. I hope the rest of you are sort of following along, and I'm hoping you are doing similar things, or at least what we were showing you was making sense. You guys did just such a great job. I don't have to do a bunch of coloring up here in front of you. You had all those examples already, so that was great. What about, just for kicks, a field like this? And just think about it a second. You don't have to sketch anything out, but just think about it for a minute, and then we'll talk about it. This is a real field. So what comes to mind as you look at this field? Thinking about if we were to repeat that last scenario where you could place structures at whim and put tile anywhere you like.
What are the units on the contours? Feet?
Feet. Yes, feet. Any thoughts? What strikes you as you look at this field?
This is the pancake that you showed in that slide.
It's like a pancake that we showed in that slide. It's quite flat. It's just inches from one end to the other. So we're probably talking one structure for the whole field. And the layout of the tile in terms of drainage water management becomes less of an issue. What factors in more are like those examples I showed in the drainage design scenario where you have a long flat field and now you've got tile at 3 foot of depth on one end and 5 foot depth on the other end. That becomes more of a factor for your design than the actual designing for drainage water management. So those of you who work in areas that have extremely flat topography have a different set of issues, but from a drainage water management standpoint, things get easier. Thoughts, comments about that?
Is this by any chance like a pump system? So at the outlet, the elevation of where we're discharging to, do we have the depth?
It could be.
Or
Yeah.
maybe talk through an example where we'd have to lift it up and over.
Yeah, it could be. In fact, many of the in this country, you know, where country, not the U.S., but in this part of the Midwest, where this field is, there are a lot of pump systems.
So in that case, could you use the pump itself as the control structure and
You
not
sure
necessarily have
can.
to put in
You
another?
sure can. That's right. You absolutely can. So you set your floats in there to accomplish your water management, drainage water management goals. Absolutely. How about a field like this? Do you walk away from it? Does it present any opportunities?
Can manage the flatter portion of it.
Exactly. Maybe from the middle on over to the left there, you get some nice, it really opens up and flattens out. Maybe from the 729 contour or maybe the 730 contour on up. So this is just a reminder that, you know, just because part of the field doesn't set up too well for us, doesn't mean we have to abandon the idea.
If the farmer is still looking at doing the lower section, if they still want to plan it, is it worth putting in tile and just not having a control structure there? Or is that actually more of a hazard than a benefit?
That would be fine. That would be fine. So your first control structure is, you know, somewhere up in here. Again, if you were running, you know, putting a main up through the middle here, through this draw, maybe your first control structure is out here somewhere. And everything down below it, if it's tiled, is conventionally tiled. And up above here is managed. If the lower part needs to be tiled. Any additional thoughts on this one?
That's where you could put in a saturated buffer or a bioreactor at the outlet to treat that uncontrolled water.
I like it. Now let's see what else I had teed up. These are just examples. I think we saw this field earlier. Again, portions of this might set themselves up for drainage water management and some parts perhaps not. Same thing with this field. You have some flat areas here, and depending on scale and the size of these, some of these areas. Again, you might get some significant benefit in these flatter areas while not worrying about at least trying to manage the water table in the more sloping parts of the field. Same thing here. So what I'm hoping is that you see an image like this and you start clicking, okay, there's the 1104, where's the 1105, where's the 1106, and the wheels start turning about you know, where your zones might be and how big they might be. Guess what? That's all the examples I had. Keegan, what do we want to do now? Do we want to go right into the post-test, or do you had some other items to share? You're muted. There
Yep,
you go.
let me get in case there's any CCAs here with the app, I'll put up that screen again, make sure I have the right sheet. And then I just have a few real brief things that I could share on, if people are interested in becoming full TSP, and maybe if any of the NRCS people wanted to jump on during that portion. I don't really feel that comfortable speaking on the behalf of the NRCS because I'm kind of a middleman there and don't want to get anything wrong. But I could go over, just how to get registered with the new NRCS system, and then there's just a couple courses it looks like, and that the manual that we discussed a few times that we'll get out as soon as this recording that I'm sure is going to turn out for us is going to happen. Then we can move into that post test, I think, because then I think we're good to go, correct? And then of course we have time for some open discussion if anybody has any thoughts. I don't want to stop that. So what's going on in the chat right now? Oh, talk a little bit about the automated control structures. Yeah, automated control structures, there's a few iterations now, and I think they have come quite a ways, and Ben can probably speak to it better than I can. There's a few different levels of automation. Technically, the float control structures, the water gates, are kind of the simplest form of automation. And then there's structures that are available that are locally programmable. So basically, you can set up the schedule on site and set it for certain times a year to move the slide gates up and down to open it up. And then kind of the Cadillac model, I would say, would be one where there's a modem out there. So you have a data plan for it, and you can connect anytime you want from your desktop and see where those water levels are and adjust those control structures. When we think about barriers to implementation to this practice, I think one of the big ones for farmers, well, first of all, I don't know if a lot of the farmers are knowledgeable that drainage water management exists and what it can do for them and for their systems. But if they're a large operation managing 2,000 acres and they have 800 acres of that in drainage water management with 30 control structures, that's a lot of work to go out there and pull those stop boards manually, especially if there is these big storm events. And so I really think moving to an automated system is going to open up a lot of acres and get a lot of interest from farmers. Especially my experience with working with farmers is they love to see data, and if they could log in online and see where that water table's at, or maybe have a soil moisture sensor in there, they can really start getting excited about what they're doing with that water management. They'll kind of see that water as another input to manage, and I think we're on the cusp of that happening. Hopefully we get a lot of momentum. Let's see here. There's some questions about EQIP covering portions of the cost. Actually had a slide on EQIP that I could share real quick if I didn't shut that slideshow down. Let's see. Share screen. Yeah, we just taking a look, and this is pulled together by Tom Christensen there of ESE, looking at 6 states, just cost share financial assistance, and kind of the different practices that we spoke about today. So the DIA 164 itself, so if there are any TSPs out there writing these DIA 164 plans, those are all kind of set across the nation, I believe. Price-wise right now, that might change over time. And once again, if anybody on the NRCS side wants to jump in and correct me, feel free to do that. But without tile maps, they're looking at about $7,000 per design. Without or with the tile map, it's just over $5,000 per design. And I think that includes construction oversight. For the producer, actually managing the control structures, it depends, if it's greater than 10 acres or less than 10 acres. On this, I just put over 10 acres because ideally we're managing more than 10 acres with a control structure on that. But the low to high end was 565 to 882, with 684 being the average for DWM. The control structures, automated control structures now are cost shareable, and I think that's what we'll probably see most farmers select here moving into the future, especially with drainage and water management. Probably not as much for bioreactors and saturated buffers. I'm not sure if a fully automated structure is needed on all those practices right now. But as far as drainage water management goes, I think it makes a lot of sense. And the low end, there's kind of an outlier. Minnesota's cost share was a little bit low on the automated structure right now. Theirs was at $2,400. The high end was just over $4,900, so about $4,000 on average. And I believe that was supposed to get to about 75% of the cost share on that. So, an automated control structure is going to run about $6,000 once we get once all the equipment gets put in there. Saturated buffers, if anybody's interested in those cost share amounts, they do it per foot of distribution line generally right now. So just under 5 to about 750 per foot on that was the range that was found. In bioreactors, there was kind of a big range on this actually. The bioreactors, we were looking at just under $60 per cubic yard. And I believe that's cubic yard of wood chip that's being put in place to $74 per cubic yard. Let's see. I did pull this slide together. This was one that we also kind of had a chat about within the Conservation Drainage Network group. Some industry partners really pulled this together. Once again, Tom Christensen of ESE deserves credit. He was the one that kind of started this spreadsheet. I refined it a little bit to put some ranges in there if we're thinking about these drainage systems. So, based on industry estimates, so there's not a lot of published data on kind of return on investment for these systems yet, but looking at the industry estimates, and this was floated around to quite a few different people, per acre investment for a pattern tile drainage system, about $1,200, estimated 15 to 35% yield increase for corn on that. So if we think of an average bushel per acre of 175 bushels per acre, and that's 26 to 61 bushels per acre, and $5 corn, which is below what we're seeing right now, obviously, but higher than it was a few years ago. That return on investment is about 11 to 25%, or 4 to just under 10 years to get to that break-even point. And that's a real basic economic analysis. There's no discounting interest rate figured in with that. Upgrading that existing subsurface drainage system to include automated drainage water management, about $350 per acre was the number that was decided upon, I guess, after really talking to the people that are putting most of these automated drainage water management systems in. Looking for that yield increase. Once again, that number is pretty variable. 5 to 10% is what we included here. That might be a little optimistic. A lot of the studies, and I think that was referenced earlier today, mentioned 5%. Well, I think 1% was even that first number that Gary threw out. But a lot of the earlier stuff really wasn't managed with kind of that yield potential in mind. With the advent of automated control structures, I think we can really start managing that water table to feed the crop. Before we set up a lot of these drainage water management schedules to be convenient for the farmer, so they wouldn't have to go out there and change outlet elevations throughout the year more than 3 or 4 times. But if that can be done remotely, I think that the convenience factor doesn't need to be as high as what it was before. So getting to that 5 to 10% yield increase, I think it's a reasonable estimate. With that, if we can hit those numbers, go over 210 bushels per acre from that drainage system that we saw before. So that increase, of 175 from baseline with no drainage to 210 with drainage, and then throw the drainage water management on top of that. That ROI is pretty significant. 16 to 31% of that additional investment into drainage water management, and so that return just under 4 years to under 7 years was the range that we were finding here. Let's see. I did have some slides real quick just on navigating NRCS payment rates, those were the 2022 payment rates. They'll probably change again coming up here for FY23. The field office technical guide should be everybody's best friend to do that. You can just do a quick Google search for the electronic field office technical guide to get to it. Otherwise, here's the website for it. It'll come up to a nice screen like this. You can select your state. I would say, section 1 is where you'll find a lot of the information about the practice cost associated with this and what those payment scenarios are. Section 4, you'll find more details on the conservation practice standard itself about what you have to meet to fit that requirement. I just selected Minnesota. Section 1, you can see state payment rates. This might look different for every state, but they all should be in section 1 for those state payment rates. What pops up on that web page might look slightly different from this, but I think if you can at least get to your state in section 1, you'll end up finding the payment rates. Minnesota, you eventually get to this. The EQIP program, usually that's a good PDF to go to find that. The practice scenarios give you a little bit more detail about how they came up with those numbers. If you click on that EQIP program, it gives you just a line by line of the different practice scenarios available and the estimated cost share on those. So you can kind of just see the range, but you just have to scroll through this PDF. This one happened to be 46 pages long with all the different conservation practice standards that NRCS works with within EQIP. If you, instead of going to the EQIP tab right here, if you go to the practice scenarios, that's where you're going to get the more detailed cost estimate for each of these practice scenarios. And there's quite a few practice scenarios for every conservation practice standard. I can't remember how many pages this PDF was, but it was a lot, I'll say that. And it's so small, I couldn't see here, so I apologize for that. But I will say it does give you a nice detailed description of those the practice scenarios. The total scenario cost will be higher than what they're actually paying out for the financial assistance. That's assumed total cost right there. So a lot of times it's going to be 75% of that, just a caveat. Let's see here. For those interested in going the TSP route, you can navigate to this page on NRCS's website, become a TSP. You used to have to get a level 2 authorization, it was called. I think that's become a little bit easier now. You need to create your verified e-authentication account with NRCS. So just follow the instructions here on this page. And once again, if there's anybody from NRCS that wants to chime in on this, feel free to do so. You can set that up. You can actually verify your account online yourself. You used to have to go into a service center and verify your identity basically, so you could get access to the eLearn. But now you can do that from the comfort of your home, or you can go to an NRCS office to do that. And it'll give you some instructions of how to obtain the TSP certification. There'll be a manual that I'll include in the binder with this class. But let's see here, I have a PDF of what we're talking about today with DIA 164, the option professional certification here. And so the ADMC certification course, which is this, of course, make sure you need to check if you need a PE or not with the new DIA 164, check with your local state conservation engineer. I would say most states are probably going to require a PE now to do the DIA 164. The technical training, once you get that NRCS registration, there will be a couple courses that you can log into AgLearn and take these courses. And then you'll need to submit a sample of your work. And once again, in that binder that's going to be included in this class, once this that recording of this turns out perfect, I'm sure we'll have that binder put together and delivered to everybody. You'll see that full description of that DIA 164 of what all needs to be included in that plan. With that, we can pull up that final test unless there's any other discussion that anybody has. Yeah, and Ben's correct. Not every state's requiring that PE license. We're still kind of getting that data. Some state conservation engineers are, checking it. They don't have, when asked, there wasn't an immediate yes or no, because they do have to kind of go back to state code and determine, what level of comfort NRCS has, with determining if it falls under their PE stamp or not. And then I'll find this the final exam here.
And I'll just add, I shared my email earlier. I'll throw it into the chat again. Feel free to reach out if you have questions after today. I'm happy to try to address those.
And if anybody wants to, I'm having trouble copying and pasting this right now. There we go.
While you're working on that, Keegan, I just want to thank everyone for being here today. I know this is a long session on virtual here, and I know it's tough. Everybody hung in there. I hope we've for those of you that are new to drainage water management, I hope we've given you plenty to think about. And for those of you who had some experience coming in, I hope there was something new for you as well. Again, you're going to be looking for a binder. There's going to be an evaluation coming out at some point. Keegan, correct?
Yeah, I have the evaluation here. We could probably give it in the chat. We'll leave it open. People are probably working on that test right now.
Okay.
But I can put the evaluation in. Otherwise, I'll email that out if people don't get to it today with that binder, but we know it's probably better to do it when it's fresh in everybody's mind. I will say thanks to everyone and thanks to Gary. This was really informative for me too. I've learned quite a bit, and I kind of teased on Twitter. I think Laura saw it, but I don't know if there's ever been this many experts in the room before for a certification course. There's a lot of I mentioned those extension universities. They're doing great work on all this. I think we had a lot of those leaders in the room today, so that really helped things along. So I hope everybody learned as much as I did.
Keegan or Gary, will there be a participant list available by any chance, or?
That's a
I'll have to
key
think.
question.
Yeah, I'll have to think about that.